Okay, so put this in your notes for section 3.1 on slopes, tangent lines, and derivatives. Okay, slopes, tangent lines, and derivatives. First thing the author talks about in this section is the average rate of change, and that's just like I always think of the average rate of change. If I said you're driving from here to Colby, and you average 70 miles per hour, that's your average rate of change. You went so many miles in a certain amount of time. That's your average. But what we're worried about in Calc is not just the average, is I want to know at mile marker 25, how fast were you going? At any instant, how fast were you going at that point? Okay, not over an average. But the author talks about the average first. So when you're reading that, think of it like in terms of miles per hour, an average rate of change. And it doesn't have to be just miles per hour. Okay, it can be any growth rate. Okay, an average rate of change is the amount of change in a quantity over a period of time the amount of change in a quantity over a period of time divided by the time period. So if I was doing an average rate of change, I would be subtracting to figure out how many miles did I go, and then I would divide by the time. Okay, and that would be like my average rate. Okay, picture-wise, the author looks at a graph in this section, and I think in this section the author was talking about the growth of the number of fruit flies. Okay, if you read that section. On this, put in a curve. Doesn't have to be exact, something like this. Okay. And then put in a line that cuts the curve. Okay, in this ordered pair where they intersect, let that ordered pair be x, and the author is using f of x for the y. And if you come down to the x-axis, just label this as x. Okay, and then the other point where the line intersects the curve, come down and label this one. The author's using this distance, and some calc books use delta x for the change in x, but this author uses h. He uses the letter lowercase h. So this x value, if this is x and this is h, then this x value is x plus h. So this ordered pair would be x plus h, comma, and then f of x plus h. Okay. In Algebra 1, we would have labeled, let's say this one we would have labeled as x sub 1, y sub 1. And let's say in this one we would have labeled this x sub 2, y sub 2. And if I said figure the slope of that line, okay, and in this case it's the slope of the, let's just go slope of the line first. Definition wise, you guys learned it as rise over run. Okay. And that's just figuring, if you look at this triangle and figure the rise, this would be the rise value and this would be the run. The rise over the run. Some authors use, for the rise, they're going to use delta y. Delta stands for change. So it's the change in y between here and here. So it's delta y over, and this run is delta x. So it's the change in y over change in x. But you guys, in Algebra 1 and Algebra 2 and Geometry, you learned it as y sub 2 minus y sub 1 over x sub 2 minus x sub 1. And that was the formula for slope. Okay. But now, if we use the new ordered pairs, if we use this ordered pair and this ordered pair, and sub into this, and instead of just calling this a line, slope of the line, this line actually cuts that curve, so it is the slope of the secant line. Secant comes from the Latin word secare, which means to cut. The slope of the secant line. So if we sub in for y sub 2, if we sub this in for y sub 2 in this formula, we'd have f of x plus h, and our y sub 1 is our f of x, and our x sub 2 is our x plus h, and then our x sub 1 was just x. Okay? And if you simplify that, out, you end up with f of x plus h minus f of x, and the x's subtract out, so it's all over h. Okay, and this is the slope of the secant line. Okay. Now, what you have to do on this next part is you have to visualize what happens if you take this secant line, okay, cuts the graph, and what happens if you take this secant line and let this h go to 0. If this h goes to 0, it's going to get smaller, smaller, smaller. It's going to approach x, okay? So you're basically going from a secant line, and this is going to come down closer, 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 where this goes to 0, and what it then becomes is a tangent line. Okay. Here's kind of a, if I can get back to this, let me see if I can get to it. Okay. This is kind of what I mean. It's taking that secant line, okay, and it's approaching a tangent line. Okay. That h value is going to 0, and then it's just going to be tangent to that curve. There are all kinds of animations if you just go on the internet and look at tangent line, secant line to tangent line animation. I'll play it one more time. Okay. Take your secant line, let the h go to 0. It's going to approach a tangent line to the curve at a specific point. Okay. Okay, so you kind of get an idea what that looks like. Okay. So go back. Now we've got the slope of the secant line. Okay, now we want to get to the slope of the tangent line. Okay, and that is what they call the derivative. Okay, the derivative is the function . Okay, and in Calc, we use the apostrophe, and you read it f prime. Okay, f prime of x. Okay, you might want to put out how you read it. You read it f prime of x. Okay, the function f prime of x is derived from f of x, whose value at x, okay, the function f prime of x derived from f of x whose value at x is defined as, and I'm going to write it out as a formula, the f prime of x The only difference is we take this equation up here and you let h go to 0. So when you let h go to 0, it's the limit as h approaches 0. Okay? Still have the same formula, f of x plus h minus f of x, and it's all over h as h goes to 0. This whole thing is the formula for f prime, which is actually called the first derivative, because we'll end up with f double prime. You can have as many primes as it will allow. And this formula, instead of being the slope of the secant line, this one is the slope of the tangent line. When you let that h go to 0, and I'm going to go through some examples. This is the slope of the tangent line. So there's a difference between this one. Whoops, wrong one. This one, slope of the secant line, and this one is the slope of the tangent line. The real difference is this limit as h goes to 0. Okay, so let's look at a couple of examples. Okay, they will give you directions. Find the derivative. Okay, and basically they're asking you for the slope of the tangent line. And the reason I emphasize that slope of the tangent line is because I went for probably a month in my calc before I found the derivative, but what did I actually find? When I found an answer, what was it? It was actually the slope of that line, of that tangent line. So first derivative is the slope of the tangent line. Okay? So find the derivative, f prime of x at the given x value. Okay? So here's the equation. They have to give you some beginning function. Okay, f of x equals, and they're going on this one it's a parabola, x squared plus 1, and they want to know what's the derivative at x equals 2. Okay, so what is the slope of the tangent line at x equals 2? Okay, okay, so let's figure, we're going to do it first, then we'll come back and graph it. Okay, so write down the formula, f prime of x equals the limit. Up in the numerator, it's f of x plus h minus f of x all over h as h goes or approaches 0. Okay? And I'm going to work this going down. I don't care if you go across or if you go down, but that limit notation stays there until you let h go to 0. So you need the equal signs. You still need this notation. Okay, what this means, if I said find f of 5, what would you do? You just sub it in, right? So I'm saying find f of x plus h. In the beginning equation or function, everywhere you see an x, you're going to put in an x plus h. You're going to sub that in. So you're going to have x plus h quantity squared plus 1. This is my f of x plus h. I'm just subbing x plus h in for that. Okay? Minus, what's f of x mean in math? F of x is the same thing as y. Okay, what is my f of x? It's this, so I'm subtracting that. You need brackets there because that minus sign is going to change. It's critical that you have brackets or parentheses or something there, because you're going to change. It's going to change signs, and it's all over h. Okay, so that first line, we're just basically substituting in. Everybody okay with that? Okay, now the pre-algebra part of this is critical. X plus h quantity squared. You can do that two ways. You can write it out x plus h times x plus h, do the long way, multiply that all out, combine like terms, or the shortcut is square the first one, be x squared. Multiply these two together, xh, and then double it, 2xh, and then square the last one, plus h squared. Okay with that? Every time you square a binomial, you should get a trinomial square. If you're doing it on the calculator, yes. Okay. Yeah, if you were doing it on the calculator, yeah. Okay, so simplify. This would give us x squared plus 2xh plus h squared, then I still have this plus 1. Okay. Now this minus, okay, it's going to change this sign, so it's going to be like minus x squared and minus 1. And it's all over h. Okay, look up here for a minute. On this, you're subtracting your f of x. If this is a regular polynomial that you're substituting in for, this f of x ought to always drop out. If it doesn't drop out, you've made a mistake. Okay? So look, x squared minus x squared plus 1 minus 1, it drops out. If it does not drop out on a regular polynomial, you've got an error. Okay? Okay, let's keep going. Okay, so we still need the limit notation. Okay, so the x squared minus x squared, that's gone. Plus 1 minus 1, that's gone. So all I have left up in the numerator is 2xh plus h squared. And it's all over h as h approaches 0. Okay? The next step, this is a polynomial over a monomial. That h divides into both of them. Okay, so if it divides in, you still have that limit notation. If I divide h into that first term, what's left? 2x. Divide h into the second, h into h squared, just h left. Okay? Once you've reduced it, now you let this happen. Okay? Let h go to 0. That means basically everywhere that there's an h, substitute in a 0. So if we substitute in a 0, what's left? Yeah. So we're left with just 2x. Okay? Or 2x plus 0, which is 2x. Notice, when I let h go to 0, this notation is no longer there. It's gone. Okay, so now my f prime of x is, my first derivative is 2x. Okay? Go back to the original. It said find the first derivative at what? At x equals 2. So what you're really doing is you're substituting in f prime of 2. So 2 times 2 is 4. Okay, so the derivative at x equals 2 should be 4. Okay? Okay, now let's check it. If that's true, we should be able to graph our original. Ooh, we're going to have to graph the line. I don't have a line yet. So far I've got a slope, don't I? Okay, this is the slope of the tangent line. What's another letter for slope? M, right? M is slope. M is the same as the first derivative. This is the slope of the tangent line. If I want to check it, I'm going to have to find the equation of the whole line. When they say, key phrase, find the equation of a line, what two things do you need for an equation of a line? You need a point and you need a slope, okay, or you could do the y-intercept. I'm going to do it using this, y minus y sub 1 equals m times x minus x sub 1. I now know the slope. I can put that back in for m, sub it in. It was at x equals what? It was at x equals 2, right? This value was 2. Ooh, now I need to know the y value. If x is 2, go all the way back to the original. If x is 2, what's this y value have to be? 2 squared plus 1? 5. So the whole ordered pair, sometimes the author gives you the whole ordered pair, sometimes the author only gives you the x value. You have to sub it back into the original. It goes back in the original. So our ordered pair is 2, 5. So when we're looking at this, 2, 5 is like our x sub 1, y sub 1. So now put 5 in there. So let's find the whole equation of the line. We know the point and we know the slope. So we'd have y minus 5 equals, multiply this out, 4x minus 8, add 5 on both sides, and y equals 4x minus 3. You agree with that? Okay, now we can check it on the calculator. Okay, let's go back and graph the original. The original equation, let's go back and put this in. Y equals x squared plus 1. Okay, let's put that in y sub 1. Y equals x squared. We know it's going to graph a parabola that opens up. It's going to intersect the y-axis at 1. So y equals x squared plus 1. You can do zoom 6 if you want to. Okay, and then let's graph the equation of our line. So y sub 2 is 4x minus 3. That's our tangent line, the equation of the tangent line. So 4x minus 3. Number one, it looks tangent. Okay, you end up with a graph looks like this, and at x equals 2, okay, it's tangent, okay, and if you go back, where should these two intersect by what we've just done? To what? 2, 5. They better intersect at 2, 5 or we've got an error. Okay, so do second function calculate, intersect. Get your cursor close to that point. Okay, press enter, press enter. Guess, just press enter. Okay, now look at what mine's doing. I don't know if yours is reading that. Mine's doing 1.99999. Yeah. Okay, that's the calculator's 2, and the 4.999, that's the calculator's 5. Okay, so don't just trust your calculator. You got to trust your algebra too. So this intersects at 2, 5. Okay. 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 So if they ask you for the first derivative is the slope of the tangent line. And our answer, if they said, what's the first derivative? You're actually done when you find the 4. If they said, what's the equation of the tangent line? Then you got to go back, substitute in. You need two things, a point and a slope. And then this would be the equation of the tangent line. Okay, I want to go through another example so you have more than one example. Okay. You might put 2 on there. We did second function calculate, intersect, and it should intersect. That 2, 5 ought to be a common point on both the line and the curve. Okay. Okay, same directions. Okay, put this for example 2. Find the derivative. F prime of x at the given x value. Okay, and on this one, say f of x is 1 over x, and it's at x equals 3. They want you to find f prime. Okay. First, without looking, what's that going to graph? Y equals 1 over x. If you cross multiply, it's going to be x times y equals a number. X times y equals a number is always going to give you the hyperbola. Okay. And they want to know at x equals 3. Okay. Okay. So let's look. F prime of x. Still start with the same formula. the limit as h goes to 0. Up in the numerator, it's f of x plus h minus f of x, and it's all over h as h approaches 0. Okay, so you still need that limit notation. Everywhere you see an x in your original, you're going to substitute in an x plus h. So if we put an x plus h in here, we're just going to have 1 over x plus h minus, and then you subtract the original. It's not a polynomial, so I can just subtract it, 1 over x. And it's all over, you got a complex fraction, it's all over h. Okay. And remember in Algebra 2, when are we going to ever use this simplifying complex fractions? You're subtracting two fractions. To add or subtract fractions, you have to get common denominator. This occurs once, this quantity occurs once. LCD is x times x plus h. Okay? So you do have to do some of the algebra. The limit notation is still there. So the common denominator is x times x plus h for both those fractions. And then it's all over h. Okay, so you have to look at this. What do I multiply this denominator by to get this? Oops. What do I multiply this by to get this? X. So if I multiply the denominator by x, I got to multiply this numerator by x. So x times 1 is just x. What do I multiply this one by to get this one? X plus h. So I got to take 1 times x plus h is just x plus h. Okay? So you got to do a little bit of the algebra first. Okay, now I recommend you use a different colored pen or whatever. This minus sign is going to change both signs in the numerator. You either change denominator, and I don't want to change the denominator because then I'd have unlike denominator. So that minus sign is going to affect that. Okay, it's going to make that negative x, negative h, and then I'm back to adding. Or you just have to simplify that. Okay, so I have the limit as h goes to, woo, I left out the zeros up there, as h goes to 0. X, now, I said before the f of x would drop out. That was if it was a regular polynomial. This is not a polynomial. This is a rational function, so a rational expression. So x plus a negative x, that part drops out. And I just have a negative h left on top over x times x plus h. Okay, now I'm going to rewrite this a little bit different. I'm going to divide by h. That's the same thing as h over 1. When you divide by fractions, invert that one, invert the second one. Okay, so we still have that limit symbol. This fraction stays the same. And I'm going to invert this one, and I'm going to go to multiplication. Now, what's going to reduce? You can't get what I call slash happy, okay? You cannot reduce like this h with this one. The only thing that's going to reduce with this is another x plus h. But I can reduce these two, okay, because there's a time sign in between. So yes, h would go in there one time and h would go in there, and you'd have a negative 1 left, okay? Okay, so I still have the limit notation. The limit as h goes to 0. I would have a negative 1 on top. And the denominator is still this times 1. So I still have x times x plus h. Okay? Have I reduced everything I can do? Yes. Now you let this happen. Let h go to 0. So everywhere you see an h, you're going to substitute in a 0. So what's left on top? Just negative 1, right? And if you let this go to 0, You have x times x, x squared. Notice the limit notation is gone. Okay, and they asked for it at x equals 3. So at x equals 3, it would be 1/9, right? Or you can write it like this too. You can also go an extra step and say f prime of x is negative 1 over x squared. And if I want to do f prime of 3, it's a negative 1/9. Okay? So if I said what's the slope, it would be a negative 1/9. Okay? Okay? If I wanted to find the equation of the line, that would be my m. My x value would be 3. I would have to substitute 3 back up into the original. What would my y value be? 1/3, right? And then you would sub that in and get the equation of the line. Okay? I will tell you on this author's a little bit different than the author I had when I first had Calc. When I first had Calc, and just so you know, depending on your author, you may see it written this way: f prime of x equals f of x. Instead of using h for that distance in between, they use change in x minus f of x, and it's all over delta x. Okay? Okay? But it's the same formula, just a different author, different. They're using delta x instead of h. Okay? Okay, the assignment, I purposely assigned the odds. You notice it took several steps to go through there. Okay? I want you to go through those and be ready. Don't come Monday and still needing to do the work. I need you with those ready to go on the board. If I say put up problem number 5, be ready to put it up on the board. Okay? So do 5 through 15, the odds on those. Okay? And be ready to put them on the board.